Hello and welcome back to Blackbird. This video is going to be about operators in Java. And within this video, we will cover all of the concepts of operators that you would require to get going till the advanced section of Java programming. So, without any delay, let's discuss the agenda. Firstly, we'll have the all type of operators. It'll mostly be a theories part. Okay, this is a no code session. It'll be theory, so it's important for you if you are making notes for your exams. You can really watch this video. We'll discuss about the associativity and the BODMAS and BIDMAS rules. At the end of this video, we might use some of these operators to write some mathematical code and not so math way. So let's begin. I cannot see my pointer. Here it is. Okay. Um, so the first type of operators that we are going to talk about are increment operators, which are denoted by two plus symbols. What they do, this operator increases the operand value by 1. You can really fast forward the video in order to understand. And it is generally used to increment LCV value, loop control variable value, during the reinitialization of a loop. It is generally used at that point of time. There are some other use. In prefix notation, it is change the value, then use. And in case of postfix notation, it is use then change. All right. So prefix notation, example of a prefix notation would be plus plus a. An example of a postfix notation would be a plus plus. All right. Second is a decrement. It's the same, but this operator decreases the operand value by 1. In case you are wondering what an operand is, it's the variables on which an operator works. This is also used for the same condition, generally used for the same condition. And in case of prefix and postfix notation, things would remain exactly the same, just the denotation would differ. In case of prefix, it will be minus minus a, and in case of postfix, it will be minus minus, sorry, a minus minus, like this. The third type of operator is bitwise not. It is a tiddle that we denote it using. It's called a tiddle. It's a bit manipulation not operator, okay, which flips all zeros in a binary to ones and vice versa. It is basically used for this purpose only, to flip zeros to 1 and ones to 0, and is used to manipulate the binary code. There is a second use of this. It also flips all false to true and vice versa. So, let's say that you have a boolean variable. Let's say boolean flag is equals true. Now, if you try printing this like this, not of flag, then the output would be false. But there is a difference here. This tiddle is used for flipping zeros and ones and vice versa. And in this case, for flipping the true and the false, you use a exclamation mark, which is it's a not operator. All right, don't confuse within the tiddle and this not operator. Then we are going to talk about a unary plus symbol. This is used to denote that the value stored in that particular variable is algebraically positive. All right, and the unary minus is used for the same purpose, to denote that the value present in a variable is algebraically negative. All right. The seventh operator is a typecast operator that we would discuss. We have talked about the typecast operator. Just for example, I'll give you this statement: double D is equals double of some variable A. So this is the typecast. It's not an operator as such, but we still want to include it here just for discussing. It is used to specify that we assign the particular value in an operand to either a smaller or a user-defined type explicitly. So I'm not going to write that. You can rewind the video if you want, or you can check out the captions or transcript for the definition. What is it used for? It is used to cast values from one data type to the other. Okay, let us move on to the next operator. Now here starts the arithmetic operators, which is a multiplication sign. It's simple, used to multiply two or more values, two or more variables. Okay, it is used for multiplication in Java. All right. The ninth is a division, used to divide. Tenth is a modulo, gives the remainder of division. Also, in this case, division. In case of integer division, it truncates the decimal part. You should note this. Okay, it by default truncates the decimal part, and the quotient is only returned in that case. Same is the case with a modulo sign. Then comes a plus. This is a binary plus, which means that it adds two values. It's used for addition of two variables. I mean, the values that are stored in those variables. The 12th type of operator that we are going to discuss is a minus, used for subtraction. Okay. These are all basic use operators that you might know about. Let's start with the bitwise operators. This is known as the right shift. So what it does is, let's say I have a value decimal number that is 35. Okay. So if I write 35 and then right shift times 2, then what it does is the decimal equivalent of 35 is 0, 0, 1, 0, 0, 0, 1, 1. And when you are right shifting it by 2, what it does is it adds 0, 0 here, and it removes this thing and shifts it to the right. So now the original was 35, but after doing this operation, what you would get is 8. Okay. So, after all of it, the resultant would be 0, 0, 0, 0, 1, 0, 0, 0, which is equals 8. But this is in case of positive. Okay. It is in case of positive numbers. In case of negative numbers, let's talk about it here. So in case of negative, let's say I'm writing minus 8 and then left shift it by 2 times, right shift it by 2 times. So what it does is the code for 8, the binary code for 8 is somewhat like this: 1, 1, 1, 1, 1, 0, 0, 0. Yeah, this is for minus 8, and times like right shift it 2 times. Then what it does, it adds two extra ones here. Okay, and these zeros get removed. So basically what happens here is the output of minus 8 right shifted by 2 times, it gives you a value of 4, a negative 4. So a negative 4 is returned, and which is binary value is 1, 1, 1, 1, 1, 1, 0, 0. So you can see that the 0 is removed from this point of, like, from here. Let's come to the 14th bitwise operator, which is unsigned right shift. It is known as the bitwise zero fill right shift operator. It shifts the bits of a number towards the right a specified n number of positions. So what should we write? Shifts the bits of a number are specified n number of times to the right, and in place of that shifting it fills them with 0. It fills the rest of the part with zeros, binary 0. Okay, this is called the unsigned right shift operator. Then we have the left shift operator, which does the same as this one but just the opposite way. Okay, so it shifts the bits of a number towards the left a specified number of times, and the syntax for this is value and left shift times none. So for example, let's say I have this 0 0 0 0 1 0 1 0, and I left shift it two spaces. So initially the value was 10, but then after that I get the value as 40. All right. 16 is a relational operator, which is greater than, also known as left crocodile famously. I mean, I'm sorry for my bad English, but it's all right, I suppose. This is a greater than operator, and I don't think that I have to explain how to use it, right? Greater than, equal to. So here there is an exception. Let's say that A is equals 10, B is equals 10, and then you are comparing A greater than B. So this would return false. But in this case, A greater than equals B would return true, because 10 cannot be greater than 10, but 10 can be greater than equal to 10, which is true. All right. These are really confusing sometimes when given in a certification exam. Okay. This is less than, equal to. No, you can really skip this part of the video because I'm finding it boring as well. I don't suggest that to my subscribers, but I mean, I also value your time. You should also value my time, but it's all right. This is the less than operator. All right. Let's move on to the next one. Then we don't really have an operator, but we have instance of. This is something important. It is a keyword, not an operator, used to check whether a variable is a reference variable or not of a given reference data type or not. Okay, how to use it? Example of using it is something like this: variable name, and then you write instance of, and then some class name, you can write it here. Okay, so just for example sake, I can write Venkat instance of human. All right, and this would give me true. Yeah, no, I'm not in human. The 21st operator is equals equals. Okay, it is an equals operator, relational again, checks for equality of the values stored in a variable. It checks for absolute equality of two values that are stored in a variable. You should note this line really carefully, because in the upcoming lectures I'm going to confuse you with this thing. Just because there is a equals method in Java which hails down from the object class, which is like the topmost hierarchy class that is present in. You should note this down really carefully, because I'll be confusing you in the upcoming lectures with this operator and then an equals method which is present in the object class in Java. Object class is the topmost class. Every class is a subclass of object class. Okay. So yeah, moving on, we need to discuss one example here. Okay. The example is, let's say I have int value a is 10, b is 10, semicolon. If I write a equals equals b, then it's going to give me true. Okay. But if I say integer a1 is equals 0, and if I again say integer a2 is equals 0, and then I write a1 is equals a2, this is going to give me false, just for the reason it checks for equality of values. In order to compare objects, you need to use equals method for reference types or object types. All right. 22nd is a not equals operator. So basically, if I say a is 10, b is 12, and if I write a not equals b, this gives me true. There is nothing that we need to know much about this one. Then comes logical operators. There is a logical and ampersand symbol. What this does is it returns true if both operands are true, else it returns false. So I need to write here only if, and for the bitwise it works quite the same. If it is 1 1, then only it will result in 1. Then there is this XOR, logical XOR operator. This you have learned in bit manipulation in your school. So I don't think I have to tell much about this one. Let's say that I have a value a is equals 42 and b is equals 15, and then I write a XOR b. This value would be 37. How exactly? I'm telling you this one. The boolean value for 42 is 0 0 1 0 1 0 1 0, and that for 15 is 0 0 0 0 1 1 1 and 1. Okay, now it finds the first place. Like let's say this is a 0 and 1. So for 0 and 1 it will result in 1, then for 1 and 1 it will result in 1, it will result in 0, then again for 0 1 it will result in 1, and in the same way it will quite literally fill the other spaces, and this value, my dear, is 37. So this was the corresponding of 42, it was the corresponding of 15. For the XOR table, it's the logical XOR combines bits of two Boolean values and results in true only if one of the operands is true. And that is why it's exclusive OR. The table we have already talked about. Okay. The 25th operator is going to be a logical OR. And we know this. If I write A or B, I'd get a value 47. Why? Because the same remaining 0 0 1 0 1 0 1 0 and 0 0 0 0 1 1 1 1. In case of OR, the value filling would be like 0 0 1 0 1 1 1 and 1, which is equals 47. All right, ready to go for the next one, which is I suppose 26th. Yeah, and the 26th is a short circuit and. Now I'll tell you why this is a short circuit and why is it not Manna Vaiga circuit. Okay. So what it does is it returns true only if both operands have similar result, or like both operands result in true. It is significantly used to combine two relational operators, and an example of this one would look something like this. Let's say this is val1 is equals val2 and this is like a 2 times ampersand, and val3 is equals val4. So these are two separate relational expressions, and the combination and the conjunction of it is done by this and operator. Now why is it called short circuit? Since if this is false, then the expression totally from here would be disregarded and the condition would be returned false, because it's obvious that if this is false, either this be true or false. This second expression, relational expression, does not care. Why? Because this is false. I need two truths in order to go forward, and if it's not, it'll just short circuit and skip. This is known as short circuit OR, and very specifically it is used to also combine two relational expressions. These are also considered to be conjunction operators, because they join in two relational expressions. So in the same condition being, but we replace it with an or operator. Even if this is false and this is true, then it will return that, yeah, no, the condition is true. It just needs one true in order. We'll learn about lambda expressions beyond this course in some other video, not right now, because studying this would need an understanding of the stream API and the functional interfaces in Java 8. And at the very end, we talk about the equals operator, which is assignment operator. All right. Let's say, I mean, you know how to use an assignment operator, but I'll show you something else. Let's say that I want to store A is equals 10, B is equals 10, C is equals 10. What I can do is instead, I'll write int A comma B comma C is equals 0. And then here I'll write A is equals B is equals C, and that is equals 10. Simply like this. So I can write this as well. Now let's talk about operator precedence. Operator precedence is the order in which, in a given expression, operators would be executed by the Java compiler. So just like you have heard about BODMAS, we have something like BEDMAS. So starting with the highest and going till the lowest, first comes plus plus and then minus minus. Then there is plus plus minus minus. Then there is a tiddle. There is a not. There is a unary plus. There is a unary minus. There is a typecast. Okay. Then there comes multiply, divide, modulo. Then there comes plus, minus. Then there is a right shift, unsigned right shift, left shift. Then the relational operators, which is greater than equals, less than equals, instance of. All right. Then there is equals equals. There is not equals. Then there is and then there is XOR. Then there is or. Then there is a logical and, a logical or, a ternary operator, a lambda expression, equals, which is the assignment, and here is where the lowest precedence means. So going down this table, you would find the precedence decreases. As we go down till the lowest precedence operator, it is executed by the compiler at the very last, and this assignment operator is at the very end, because after performing all of these things, you're gonna store it in some variable, right? And to store some value in the variable, you need to assign it, and that is why assignment operator was placed at the very end of the operator precedence. There is something known as associativity. Now this is a rule which states that given multiple operators of same precedence, the execution in that case for the expression will either be from left to right or from right to left. Just in this case, I would like to state an example. In case of an assignment operator, associativity is from right to left. So let's say I write here int abc is equals 10. You see that there is a assignment operator here, and the way it goes is from this way, right to left. All right. Acha, this plus plus and minus minus is postfix, and this one is for the prefix. Okay, prefix comes here. That's it for this video. I hope this was a really boring video for you, but I had to do it since I am making a full-fledged Java course, and this was a really important topic to talk about. Well, thanks for watching this video. In the next one, we'll be discussing about control statements, and it won't be that irritating. Okay, thanks for bearing with my voice. If you like the video, uh, just like, subscribe, and share it with your friends. Thank you.